Nature's Phoenix, second edition, is now available to purchase. It's packed with valuable insights on fire ecology, including the topics we'll be covering in this episode. If you're interested in learning more, you can find a link to purchase the book in the description below.
Welcome back to the webinar series, Chronicles from Nature's Phoenix, where co-authors Dr. Dominick DellaSala of Wild Heritage and Dr. Chad Hanson of the John Muir Project share the screen with other renowned wildfire experts.
In the sixth and final episode of the Nature's Phoenix webinar series, Dr. Dominick DellaSala and Dr. Chad Hanson, authors of Chapter 2, Ecosystem Benefits of Megafires, explore the overlooked ecological advantages of these large fires. As climate and weather extremes fuel more megafires, discover how they drive biodiversity, support fire-adapted species, and challenge conventional wildfire management strategies.
Well, welcome everyone to the sixth and final webinar in the Nature's Phoenix Wildfire webinar series. Thank you for joining us. I think this has really been a fantastic series. Again, this webinar series was created in conjunction with the release of the second edition of the book, Mixed Severity Fires, Nature's Phoenix, and has been exploring different chapters, different themes in the book. And today's episode is Megafires, Catalysts for Ecological Renewal, and that draws from Chapter 2 of the book, and there's a bit of the overview from that in this slide here. Before we get into our presentations, I just wanted to briefly reflect on the overall arc of this series, because I think it's been tremendously helpful in getting at a lot of key themes related to fire and misunderstandings about forest and fire and their implications for policy. So this is the sixth episode. In the first episode, we touched on the climate fire nexus, looking at the issue of what it means to have fire in a climate altered world, while also holding in our hands at the same time the knowledge that big mixed severity fires have long inherently been a part of forests and other ecosystems, and a particular attention to the way that logging projects done under fire-related justifications are causing large-scale carbon emissions and contributing to the climate crisis. In the second episode, we heard about how birds and mammals use the habitat created by severe fire, those post-fire habitats, and how those are not the sort of moonscapes that they're generally portrayed, but in fact, that intense fires create some of the most vibrant and diverse forest habitat that there is out there. The third episode took on the overgrown forest myth, that narrative that says, oh, we have a fire problem now because there's too much forest out there. And it helpfully dissected the different ways that myth is propagated and how to debunk it, and in fact show that the sort of things that are being proposed are leading to a forest depleted of carbon, not an overgrown forest, but a depleted forest. The fourth episode looked at the ecological costs of post-fire interventions. So again, sort of building on that myth that after fire, you just have a moonscape, a lifeless moonscape. So why not just cut it all down? Our speakers did a great job of documenting how the sort of great post-fire habitat we learned about is lost in these post-fire interventions, and also a similar process in terms of post-beetle forest areas as well. And then our most recent episode was Rethinking Wildfire Management Beyond Backcountry Logging. And that was both a chance to look at the public safety side, and Dominick shared a very personal account of his community being impacted by fire and what it takes to actually make fire-safe communities that can safely coexist with fire. And then to hear about the sort of absurd, unhelpful, and ecologically damaging projects that continue to happen in the backcountry continue to be proposed in the backcountry by the Forest Service, and how that's a dead end and a waste of resources and ecological damage, compared to focusing on working from the home outward. So with that, we get to our final webinar, Megafires Catalysts for Ecological Renewal. Our two presenters are Dr. Dominick DellaSala and Dr. Chad Hanson. I'll begin by introducing Dr. DellaSala. He's the chief scientist at Wild Heritage, and he's the former president of the Society for Conservation Biology North America section. He's an internationally renowned author of more than 300 peer-reviewed papers and 9 award-winning books on forests, climate change, endangered species, and speaking truth to power, as well as being an editor of multiple scientific journals. He's also been widely quoted in the national media on forest and fire issues. Dominick has served on several committees, including White House task forces on forests and Oregon's Global Warming Commission Carbon Task Force, reporting to the governor. Dominick is motivated by his work to leave a living planet for his 2 daughters, 4 grandkids, and all those that follow. So let me turn it over to Dominick.
Thanks, Doug, and welcome everybody. I'll begin with a quick anecdote about how I feel about all of this, in particular, my personal views on there's always light in the darkness of times. And I think many of us are feeling that today. And I've learned that through my discovery in forests. And back when I had just finished my temperate and boreal rainforest book, I took a hike one day with my then 8-year-old daughter, and we went up to this beautiful overlook above the town of Ashland, close to where I live. Did our hike through an old growth forest and came out of the old growth forest, and we're in a very severe burn patch where all the trees were dead and there were snags. And we sat down to eat our lunch that day, and we were surrounded by life. And it was just truly amazing. It was populated by all kinds of different pollinating insects, birds, you name it. And the place was alive. And in fact, while I have grown to appreciate old growth forest in my 4 decades, I was neglecting this other forest type. And I learned an important lesson that day. Got a hold of Chad. We put together the first edition of the book Megafires, which has been helping people now for many years. And then our publisher got a hold of us and said, we want you to do a second edition. And so now what you've got is a more updated edition that has tons of science in it, and that builds on that initial experience that I finally am starting to understand after 4 decades what a forest is. It's not all green. And there's a lot of life in that blackened forest. So if you can kind of keep that in mind as the backdrop to the conversation today, I'll launch into my shared screen and get into the specifics of what I wanted to talk about in this, our last installment of Nature's Phoenix, the webinar series. So I encourage you to go out and get the book. I think it's okay. It's selling for a bit less on Barnes & Noble than it is on the Elsevier website. So you might want to keep that in mind. So let me enlarge my screen here, get into the slide mode. Okay, so I think that should be okay on your end. Is that what you're seeing, Chad, on your side?
Looks good.
All right.
Hey, Dominick, I'm seeing a bit of extra around it. I'm not sure if there's anything to be done about that, but I can see your screen. I can just also see your control bars on the top and bottom.
Yeah, I don't know if I could. There you go.
There.
Thanks.
Okay, thanks.
For that. So my part of the talk today is going to not only get into the book and the chapter on megafires, but it's going to borrow off of the publication that we did in 2022 that was published in the journal Biological Conservation that laid out the problems with Western U.S. fire suppression and Megafire active management approaches, which we have abbreviated as MAMA. And you'll see that through the presentation. And so we actually were able to open a science article with Greek mythology. And in the Greek mythology version, it's the infamous Sisyphus who is captured by Hades. He was actually trying to capture Hades and chain him up so that death wouldn't happen anymore. And instead, Hades pulled a fast one on Sisyphus, who has to now push this boulder uphill while Hades continues to let the boulder fall back down. And that is pretty much the analogy of Western fire suppression and MAMA approaches. This lovely graphic that Bryant Baker put together illustrates the issue in general, and how in that article we said that the Forest Service was a contemporary Sisyphus pushing this massive boulder up an increasing slope that Hades, climate change, was laughing at the top. We've had this decades-long war on fire, and that has been joined now with the companion version of Megafire active management approaches to match up with the contemporary version of Sisyphus beating Hades as the climate change chaos rages on that is pushing against anything that we do on the ground. This is a figure that was in the Sisyphus article, and it shows the expenditures over time and area burning over time. And as we throw more and more money at this, Sisyphus gets nowhere because the boulder gets steeper and bigger and bigger, and the hill steeper and steeper. So we throw more money at a problem that we can't solve because there is a top-down driver in all of this that's being neglected. And that's Hades, the harbinger of climate change. So throwing even more money at this is adding to the Sisyphus problem. And this is, you can see these numbers here. Thankfully, Chad and JMP provided this to me when we were putting together the article. Excuse me. But you can see a lot of money is going into efforts to treat the problem on the ground, the perceived problem. And we've got the infrastructure mandates of logging 10 million acres on public lands in just 6 years and 20 million acres in 9 years following. Billions of dollars, subsidized logging, biomass energy utilization, all of this is counterintuitive to what really needs to happen. Now throw on top of that the Inflation Reduction Act, which throws another $2 billion at commercial logging for so-called fuel reduction and restoration approaches. And those federal funds are being matched by private and philanthropic funds, particularly the Nature Conservancy, which is heavily invested in this, as we discussed in the last webinar. None of it's going to work. And it won't work in a climate changing environment. We've got to get to coexistence, which a lot of scientists are now saying that this issue is going to fail, regardless of how much money we throw at the issue. And mainly because of this. And of course, this graph needs to be updated now because it's a bit outdated compared to when we first put it in the book. But you can kind of see the pattern here. Early 1900s, there was a lot of fire acres, mostly in the West. And there was a warm Pacific decadal oscillation period, which is the climate coming out of the Pacific Basin that affects the Western United States. So there was a warm-up, and that warm-up was associated with high amounts of fire burning through the West. The so-called Big Burn happened during that period, a 1910 fire that affected millions of acres in the Rockies. And then you go to the mid part of the century, there was a cooler Pacific decadal oscillation in the Pacific Basin. And notice what happens to acres burning. This is at the time when the Forest Service was really starting to flex its suppression muscles and getting industrial with its fire suppression. And it was also post-World War II, so there was a housing boom. So we're building houses during what is perceived as a safe period, the cool PDO. Now let's fast forward to the 1980s to contemporary times, and you can see what's happening. So the perfect storm now is that we've got this mass influx of homes in the so-called wildland-urban interface during a warm PDO triggered by Hades. So this is the perfect storm. And the way we are treating the landscape is only amplifying these impacts. So we've got before, during, and after fire suppression all happening on very large landscapes now. As covered in our Sisyphus paper, before fire, there are bulldozers being applied in even wilderness areas. Those are the true fire scars. I don't like using the word fire scar because the fire perimeter is really not a scar. It's a resetting of nature's successional clock. The only scar that's out there are the ones that we leave on the landscape. Those are wounds that don't heal. And you've got pre-logging, and you've got lots of burning happening. Most of it is in burning piles and not necessarily broadcast burning. You've got roads. All of this is before fire. Then you have during fire, massive suppression forces, even when fires can't be put out, are being thrown at these ecosystems with major consequences. And then, of course, after fire, post-fire salvage logging. Now you combine that with unprecedented sprawl that you saw in that cool PDF that started it. And then you've got the optics of politics, misinformation, disinformation, constraints on forest protections. All of this presents us in the conservation community with a Rubik's Cube of complex problems to solve if we want to protect areas that we care about. And really what it comes down to is the decision makers and the land managers are refusing to work on the real solutions, which is climate chaos, Hades, combined with amplified industrial logging and roads. So many of you have to deal with this issue all the time with the Forest Service and the BLM marketing and branding their projects as restoration, forest health, resilience, but really they are all forms of forest degradation. We have a very large paper in the final stages of peer review that hopefully will be out really soon, showing this approach and how you can quantify degradation and compare it to what is being called restoration and resilience. It's a global analysis. A dozen scientists are on it, and there are case study examples from all over the world, including the West. And so what we argue is in order to really know if you're doing restoration, you have to have a reference condition of high integrity and then look at how those practices move the area of interest away from that of high ecological integrity. Most of the Forest Service and BLM projects don't have reference conditions, especially in the understory, and so you get degradation. And you get this, which is what we are seeing all over the landscape, cumulative impacts amplifying that of climate change, roads, post-fire logging, pre-fire logging, cows, invasive species, taking out large fire-resistant trees. All of that is degradation. It's not restoration. Now, the advocates of MAMA are going to they're going to claim that they're doing this to protect large trees. And we can talk about what are large trees. But before I get to that, I want to say why large trees are important. And you all know this, but I'll just remind everyone that large trees are generally insulated from most fires. Now, that doesn't mean they won't get killed in a fire, but that thicker bark as the tree ages provides them with some resistant properties to many fires. Eventually, they're going to get it, just like any other living organism on the planet. Everything lives and dies, or everything that's been alive is going to die. Even the old sequoia groves over time will experience high severity fire, and some of them will die, as Chad will tell you. And then there are the resilient properties of these forests that allow them to experience seed rain, that allows the seedlings to come in, and those seedlings are nurtured by the dead parents, so to speak, that are shading them, providing them with nutrients, holding on to the mycorrhizae that are going to provide the chemical connective pathways for those trees to eventually prosper. Life and death in these forests are connected. And who the heck knew that this was happening, right? So this below ground avatar-like communication network that occurs in mycorrhizae pathways that are impacted even by selective removal of the large parent trees. So when we talk about large trees, you'll hear some of the science folks that are behind the agency proposals say, yeah, we got to take out some large trees to protect the other large trees. We have no idea how this is affecting subsurface connectivity or the nutrient cycling pathways in these forests. And we see projects like this. This is from Luke Rudiger's photograph of a BLM thinning, so-called fuel reduction project. The tree in the center is a 19-inch ponderosa pine, retained so that the 32-inch and the 42-inch Douglas firs are removed. Those are bigger trees that are fire resistant, yet they were trying to move the site to pine, a dry pine site, and take out trees that are hundreds of years old and calling that restoration, even though those trees are fire resistant, as well as the ponderosa pine is. And we get projects like this, again, supported by the Nature Conservancy and their collaboratives. Fuel reduction projects that open up the canopy for critical habitat needs of spotted owls. The spotted owls are not an open canopy species, although they can use fire systems in a bed and breakfast kind of approach, where the surviving trees are the bed, so to speak, the nest platforms, and the burned areas are the kitchen for wood rats. Yet the treatments that are occurring in these areas are taking out far too many trees, opening up the canopy, causing much more damage than the fires that they're expecting to or anticipating they can reduce. And yet this is getting through at all levels of the agencies, including approvals by Fish and Wildlife Service. Again, the degradation piece comes to mind, that what we are seeing in these landscapes regarding the mammoth approaches is not restoration, it's a form of degradation. And again, that manuscript is at the final stages of peer reviews. We're dotting the I's and crossing the T's, and hopefully it'll be out real soon, and it'll help you folks deal with the misbranding of these projects. I like that guy holding the beer glass over there. You know, I'll quit drinking by 2050. And that's the situation we are in with Hades and climate change. We don't have until 2050. We are at the wrong end of this issue. And the more emissions that we put into the atmosphere, the more we are going to amplify the kinds of effects that are occurring now with bigger fires across landscapes that are being amplified by the degree of logging. And it turns out that logging at the scale of what they want to do to influence fire behavior is going to throw more emissions into the atmosphere than the fires themselves. And so that just creates this vicious feedback loop with more emissions, more future fires, and so on. And we're seeing this in several biogeographic regions. In Australia, my colleagues are reporting this. In Canada, we just published a paper in Quebec and Ontario showing the 2023 fires with all the smoke that impacted the eastern seaboard was the result of a climate-driven event amplified by clear-cut logging in that system. We're seeing it in Western North America as well. Whoops. I wanted to say something about thinning, but I'm not going to go backwards again. But you get this issue of whether or not thinning works and whether prescribed burning works. They can work under certain very restricted, limited conditions to lower fire intensity. But those conditions mean you can't be operating in extreme fire weather. You have to maintain the forest overstory canopy, the large trees. You do some light thinning from below, some burning from below, and then maybe you're lucky enough to catch a lightning bolt. But those conditions are so restrictive that they will not be consequential on a large scale basis without type converting major areas to push them towards reduced flame lengths. And so there are huge trade-offs. Prescribed burning has some ecological value, there's no doubt, and so does cultural burning, but it is not a panacea for the climate-driven fire events that we're getting today. The MAMA folks are also completely blind to human-caused ignitions, where the vast majority of wildfires across the US are caused by people. So if you're concerned about fire, close the damn roads, obliterate the roads, have travel restrictions on public lands during high fire weather. That has to be part of any kind of fire strategy, but the agencies have ignition blindfolds on, and they're only looking at so-called hazardous fuels and not the ignition factors that can be controlled. Can't control lightning, but you can reduce human-related ignitions. I just wanted to, I'll skip ahead of this because I want to make sure that there's time for Chad, but and his full presentation along with Q&A, but I wanted to kind of just get into the damages after fire, and we gave a webinar a few weeks ago about post-fire logging, so I'll just summarize this real quick. And of all the types of logging that are out there on the landscape, this is the worst by far. And there's consensus from lots of scientists on this is really bad news for fire-adapted systems, and yet we see this as part of the so-called restoration agenda. Okay, so the last few slides I want to end with is that the perspectives on this matter so much. As I mentioned in my anecdotal remarks early on, I thought I knew what a forest was when I published my rainforest book. And it wasn't until an 8-year-old opened up my eyes that, oh man, I'm missing a lot out here. And every time I go into nature, I find something remarkable, surprising, and something that I didn't know about. And so the way we look at these ecosystems determines how we value them, what we want to do to them, what we want to derive from them. If we see this landscape as a tinderbox ready to burn up, we're going to design our projects that way, whether we're a scientist or a manager. If we see that ecosystem as, wow, that is so biodiverse, nature's phoenix, we're going to love it the way it needs to be loved, and we're going to work with it for the benefits that we and nature both derive from mixed severity fire systems. And this is, a good example of a mixed severity system. Pyrodiversity begets biodiversity. The U and the L is unburned, lightly burned. H is high severity. M is moderate severity. We like seeing this. This is a healthy fire when we see this. It's not a disaster. And our perspectives really matter because biodiversity is really full in these mixed severity fire systems. It's not a catastrophe ecologically. And yet we get this. The Obama administration's parting executive order 14072, the MOG threat assessment, and the National Old Growth Amendment all blame insects and fires as the threat to these forests, not logging, when in reality, it's the reverse. And so this is a major disappointment of the outgoing administration because we're not getting the protections that we want for older forests, and especially when those older forests experience severe insect or fire issues. And it's not the protected areas that are the problem, as we discovered in the Bradley et al. Study. The protected areas are actually burning the way nature intended them to burn. The left side of the figure shows the lower levels of burn severity. The right side of in protected areas, the right side shows higher levels of burn severity in logged areas. And yet protected areas are held back because of this issue. Okay, so here's my parting slide. We got to get to coexistence, and that shift has to happen in attitudes and perspectives, and then how we view and treat the landscape and each other. Framing misinformation is to blame for the situation that we're in. Managers blame dense fuels. They treat the system with projects that aren't restorative. Loggers blame forest protections, not logging. Lawmakers issue blank checks for MAMA. The media sells fire hysteria. The public reacts legitimately to fear of fire. As mentioned, I lost half of my community. And collaboratives provide the cover for the Forest Service to push through really bad projects with minimal review. That's what we're up against. And all of this needs to result in a shift in how we are treating the ecosystem and the planet. That means less emissions have to go into the atmosphere. That means we have to protect these natural areas for their carbon assets and all the myriad of values that we're going to need increasingly from them in a changing climate where Hades is getting bigger and bigger. And we have to prioritize home treatment, defensible space to get to coexistence. So I'm going to end with that and then flip it back over to Doug to introduce Chad. But I wanted to kind of leave you with this in terms of how we see the world and each other really matters in how we communicate. And we need a different lexicon on how to treat these systems that, in terms of speaking about fire, it's not a disaster. It's not a catastrophe. It's a rebirthing event. And so thanks for listening, and I'm flipping it back over to Doug and ending my screen share.
Great. Thank you, Dominic. Thanks so much. And just to remind everyone, as with the previous webinars, we're going to save all the questions till the end. Feel free to start posting your questions, though. The way that we're going to be sharing them with the speakers is through the Q&A section on the Zoom. So please put your questions there and feel free to get started with that now. So with that, let me introduce our other speaker. Dr. Chad Hanson is a research ecologist and the director of the John Muir Project of Earth Island Institute. John Muir Project is headquartered in the Sierra Nevada mountains of California and also has an office in Washington, D.C. Chad has also served on the National Board of Directors of the Sierra Club. He has a PhD in ecology from the University of California, Davis, with a research focus on fire ecology and conifer forest ecosystems. He has published several dozen scientific studies and articles in peer-reviewed journals pertaining to forest and fire ecology and climate change. In 2017, the New York Times described Chad as being on, quote, the cutting edge of ecological research, end quote. Chad is the author of the 2021 book, Smokescreen: Debunking Wildfire Myths to Save Our Forests and Our Climate. And he is co-editor, along with Dominic, of the 2015 book, Nature's Phoenix, and the newly released second edition of that book. So let me turn it over to Chad.
Well, thank you, Doug, and thank you, Dominic. Sharing my screen here. Hopefully that works out fine. Can everyone give me a thumbs up if you see my screen okay?
Yeah, it's good.
Good. All right. Good. Well, yeah, I'm going to focus on a few examples, specific examples of very large forest fires and some research that's been done after those fires were out. After the media described them as moonscapes and as being nuked by the fire and as catastrophic, wastelands and things like that. And then, if these areas were not post-fire logged, usually because of successful litigation, then sometimes scientists come in and do some research and find out what's really going on in these areas. So that's what I'm going to focus on today before we do Q&A. And of course, you can get much more information in the second edition of Mixed Severity Fires: Nature's Phoenix. And you can get that in Barnes & Noble or Amazon or through the publisher, Elsevier. All right, so this is a mature old forest that burned at low intensity, and that we are all familiar with these forest ecosystems, large live green trees, and they're beautiful and they're wonderful and biodiverse. And there's a lot of different species that need these ecosystems and benefit from them. Um, and from the low intensity surface fire that burns occasionally in these areas. And that is a natural part of forest ecosystems and of fire regimes. And that is good. It's not the only thing that's good in wildfires. It is also good when you have high intensity fire patches in forest ecosystems with a natural mixed intensity fire regime, which is true of most forest ecosystems in one way or another. Certainly true of ponderosa pine and mixed conifer forests, and also upper elevation forest types in the western United States. It's natural to have a mix of low, moderate, and high intensity fire. And this is an area that was created by a large patch of high intensity fire. I took this picture at 12 years post fire, and you can see the richness and complexity. This is all natural regeneration. You see the standing snags, the fire-killed trees, the down logs replenishing soil nutrients. You see the enormous abundance of regenerating conifers of different species, fir, cedar, pine. You see uh, uh, dogwoods and oaks and lots of different flowering shrub species. This is a rich, complex system, and Dr. DellaSala and I termed this complex early seral forest in a paper we published about 10 years ago. Now, just to underscore this point, it is natural to have low and moderate intensity fire in ponderosa pine and mixed conifer forests of the West, including of the Sierra Nevada. It is also natural to have high intensity fire patches, including occasionally very large high intensity fire patches. And this is a map that was created by the United States Geological Survey researchers in the late 1800s. And basically, the map represents large, high intensity fire patches where 75 to 100% of the trees were killed over the course of the entire 1800s, a century long period. And they reconstructed that. And that's what those white crosshatch polygons represent. And you can see that if you look at the scale at the bottom in terms of what 10 kilometers represents, these are very, very large high intensity fire patches. They did not map anything less than 80 acres in size, to be clear. So this is all just the larger ones they mapped. And what matters about this is that not only is this natural, but very large forest fires always have a component of high intensity fires. Sometimes it's 5 or 10%, sometimes it's 20 or 25%, sometimes it's 40 or 45%, depending upon the year and the drought conditions and the weather conditions and the forest type. It usually is in that 20 to 25 or 30% range, most fires. And it creates some of the very best wildlife habitat that we have in our forest ecosystems in the West. And I'll just give a few examples here. So in the Biscuit Fire of 2002, about 500,000 acres burned, southwestern Oregon. In large high intensity fire patches and high intensity fire patches that reburned at high intensity. So high intensity from an earlier fire and then burned again at high intensity in the Biscuit Fire. These are the areas where the scientists found the highest native plant and bird species richness and abundance. And in other words, these are ecological treasures, not catastrophic wastelands. Similarly, in the McNally Fire of 2002, about 150,000 acres, southern Sierra Nevada, scientists found higher bird species richness in the so-called megafire than in adjacent unburned old forest. And interestingly, Dr. DellaSala and I did some research on this and looked at how common across the landscape are these large high-intensity fire patches, and in particular, the interior areas of the large high-intensity fire patches, because we hear a lot about this. It dominates so much of the media coverage and the political discourse, and the narrative coming out from agencies that engage in logging, like the U.S. Forest Service and the Bureau of Land Management. They're always talking about these very large high-intensity fire patches and these interior areas that are more than 100 meters, more than 200 or 300 meters away from the nearest live tree edges. And it turns out, we did a analysis, a multi-decade analysis, about 3 decades, and found that only a tiny percentage, tiny fraction of 1% of these areas are actually interior spaces of large high intensity fire patches. Most of the areas that burn are low and moderate intensity, or they're small high intensity fire patches, or they're at the very edges of large high intensity fire patches, less than 100 meters from live trees. So this notion that you have huge areas of the landscape, large percentages in these interior areas of large high intensity fire patches, that's not what we're seeing from the data. But let's talk about those interior areas, because it turns out that even though they're just a fraction of 1% of the landscape, that 13% of bird species are selecting these interior spaces of large high intensity fire patches, long distances away from the nearest live trees. And that's really interesting. And it's not just species like some woodpeckers. A lot of these are shrub nesting species that depend on the montane chaparral, these flowering plants that grow in naturally and proliferate after high intensity fire. And so that should tell us something ecologically, that when it's a tiny fraction of 1% of the landscape right now, it would have been more historically under a natural mixed intensity fire regime. We're getting closer to natural levels. But when 13%, more than 1 out of every 8 bird species, is selecting those areas, that tells us it is very, very important ecologically, and it needs to be a component on the landscape. So, one of the species that really depends on these larger high intensity fire patches in mature and old forest is the blackback woodpecker. And these birds have evolved to depend on the larvae of wood-boring beetles that themselves depend on recently fire-killed trees in order to reproduce. The wood-boring beetles need intense fire to kill a bunch of trees so that they can lay their eggs, and their larvae can develop on the charred bark of a fire-killed tree, and the larvae bore in underneath the bark and develop into adults over time. The woodpecker eat the larvae of the wood-boring beetles while they're in these fire-killed trees, these snags. And one blackback woodpecker will eat about 13,500 wood-boring beetle larvae every single year. So you need a lot of fire-killed trees. And for this reason, blackback woodpeckers select interior areas of large high intensity fire patches. And that's what the research is showing. And especially in areas where there's very large densities, high densities of large snags, medium and large snags. And Tanya Chi and others and I found that in a paper we published in 2020. And this was in the Rim Fire that, again, burned over 150,000 acres. And sorry, I meant that's a typo. It should be over 250,000 acres there, the rim fire. And high intensity fire patches also create a superabundance of morel mushrooms. Another study looked at the rim fire and found that, and that provides great food for small mammals. And in turn, small mammals provide great food for California spotted owls. And it turns out that before all the post-fire logging that happened in various places after the rim fire, which again was 257,000 acres, sorry about the typo there, before all the post-fire logging, just in the natural post-fire environment, the California spotted owl occupancy at 1 year post-fire was off the charts. It's some of the highest levels of California spotted owl occupancy that I've ever seen in recorded scientific studies or agency reports. And that's from the Lee and Bond study from 2015. And a big part of this is, as Dominick mentioned, it's the bed and breakfast effect. The spotted owls nest and roost in the lightly burned areas where there's still mostly live trees and high canopy cover and high live tree density, also snags, down logs, etc., but mostly high tree density. But if it's close to a large high intensity fire patch, they will go out of their way to forage in that large high intensity fire patch because that's where the small mammal prey base is the highest. They have the most food there. But if post-fire logging occurs, it destroys all those benefits, and spotted owl populations plummet after post-fire logging. And so, we call this, as Dominick mentioned, we call this the bed and breakfast effect, because spotted owls really benefit from both lower intensity fire in dense old forest for nesting and roosting, and high intensity fire in dense old forests for foraging to get the food they need to survive. And interestingly, reproduction goes up, as you might expect, in spidal territories that have had mixed intensity fire effects with significant amounts of high intensity fire, because they have the best food resources available and the best mix of that lower intensity fire areas for nesting and roosting and the high intensity patches for foraging. Another one, 538,000 acre wildfire, Arizona, 2011. Scientists found that Mexican gray wolves, black bears, mountain lions, elk, and mule deer all increased in populations in the larger high intensity fire areas. So they benefited. A lot of these, these are species that are, in many cases, keystone species ecologically in the forest, and they're benefiting from these, not just a really, really big fire over 500,000 acres, but in particular, large high intensity fire patches within that big fire. So again, yes, low intensity surface fire is natural. It's good, but so is high intensity fire, natural and good. And many species benefit from it and need it as part of the mix and part of the component in these, as a component in these forest ecosystems. Another a large fire in Southern Oregon, not the Biscuit Fire, different one. Researchers found that wild bee abundance was 20 times higher, and species richness of wild bees was 11 times higher in large high intensity fire patches as compared to lower intensity surface fire areas. So again, you cannot deny or ignore the research that is telling us loud and clear that these areas that burn hot, where most or all the trees are killed, are incredibly rich, important ecologically to countless wildlife species, vertebrates, insects, as well as plant species. And this is a sign that I quoted from the entrance to the Merced Giant Sequoia Grove in Yosemite National Park. And the Park Service these days is now trying to jump on the bandwagon and promote this mythical notion that it's only low intensity surface fire that is important to these these ecosystems, and is it's the only thing that's natural or good. And they're trying to say that's true for giant sequoias, and they use that narrative to justify a logging project in this giant sequoia grove. Did a lot of damage. This is on national park lands in Yosemite National Park. And what they're saying is completely contradicted by the science. Giant sequoias, yes, low intensity fire is natural, but so is high intensity fire, both small patches and large. And it turns out that giant sequoias regenerate most abundantly in high intensity fire patches, much more so than in low intensity surface fire areas. And the sequoias, the seedlings grow much faster. They survive at much, much higher rates. And so it's because giant sequoias are serotinous. They have evolved to depend on higher intensity fire to effectively reproduce. The heat opens the cones, releases seeds. The high intensity fire consumes the thick duff and litter on the forest floor, turns it into a nutrient-rich bed of mineral ash that helps the seedlings grow and become mature trees and grow and thrive for many, many decades to come. And then, of course, it gives them the high levels of sunlight that they need in those early years of their life. And this is a picture of my friend and colleague Ara Marderosian in the Redwood Mountain Grove in a large high intensity fire patch in a large fire, the KMP complex of 2021. And these are giant sequoia seedlings that you see quickly becoming saplings. That's at less than 3 years post-fire. And some of these were already over 3 feet tall. And they're now much taller than that. Conversely, in areas where the Forest Service or the Park Service these days engages in what they call post-fire restoration and reforestation, we see utter devastation. This is the Nelder Grove, a giant sequoia grove on Sierra National Forest. This is what the U.S. Forest Service did in the course of what they called restoration and reforestation. And really, this was a post-fire clear-cut logging project, and they killed 83% of the giant sequoia seedlings and saplings that had naturally regenerated after a fire that had occurred several years earlier. And we documented that in a paper we published earlier this year, Hanson et al. 2024, several of us. And so the message is it's better to let nature do the restoration. In giant sequoia groves, it looks like this if you leave it alone. This is the Nelder Grove 2, same high intensity fire patch as the picture I showed a moment ago. But this area, it's all natural regeneration, no logging, no planting. This is what the sequoias are doing. This was at 6 years post-fire. These were already 7 or 8 feet tall or taller. All right, so I will stop screen sharing there. If you want more information beyond our Nature's Phoenix book, you can check out Smokescreen, and happy to answer any questions.
Great. Thank you, Chad. So again, please feel free to start posting your questions in the Q&A section on Zoom. And I will read the first question now. This one says, Dominick mentioned amplification. Can he explain that just a bit more?
Yeah, thanks for that question. To amplify something would be to project it on an even bigger basis than if that driver of change wasn't present. And by that, I mean, you already have climate change operating on these forest ecosystems. Now, when you pile on logging, road building, cows, ORVs, you name it, you're amplifying those impacts. So the cumulative approach, if you add all of those impacts together, is the amplification that will only make the ecosystem response more towards novel conditions that those systems cannot handle. You get to a point where you can push these ecosystems past thresholds and tipping points by having too many disturbances superimposed on top of them too frequently and too much. And so that's what I mean by amplification. So you add all those disturbances up, and you already have climate change operating on the system, you're going to get a bigger impact to that system than if you just had one of them operating individually.
Yeah, and I'll just add to that briefly that the additional amplification is the fact that the pre-fire logging, usually conducted, under the guise of, terms like thinning, and the post-fire logging both increase carbon emissions into the atmosphere dramatically over and above wildfires, and in fact, much more so than wildfires, several times more typically per acre. And that, of course, makes climate change worse, which in turn influences fires. So you get these feedback loops that are self-defeating and frankly insane at this point in the biodiversity and climate crises.
Yeah, just the one other thing to build on what Chad just said, and I know you're going to shake your head with this, Chad, but there was a newspaper article, I think it was last week, quoting Hugh Safford, saying we need to have a lot more trees removed from the forest if we're going to have forest in the future. Now, what he didn't say is by removing a lot more trees, they're treating the atmosphere as a dumping ground for CO2 emissions that then feeds back on that same area at some point in the future, giving us bigger fires. So it's almost like they don't want to acknowledge the impact of emissions contributing to that feedback system that they are trying to prevent. But in reality, they're amplifying and causing more damage to the future forests.
Yeah, totally agree. And not only that, they're denying the fact that there's an enormous amount of scientific evidence, including much of it by U.S. Forest Service scientists, finding that denser forests do not burn more intensely. And so that this whole notion that if a forest is really dense, you've got to remove a bunch of trees if you want to reduce fire intensity. That notion is very, very suspect scientifically, based on a lot of evidence. I really see this in a way as a new type of climate denialism, because they're denying the central role of the climate crisis in driving increases in fire and driving a lot of extreme fire behavior. They're denying the role of logging, both pre-fire and post-fire, in making the climate crisis worse. And then claiming that the issue is that the forests are overgrown, and therefore the solution is to pull a lot more trees out of the forest. And we know what that does. It won't stop climate-driven fires, and it will make climate change even worse. So, this is really a dangerous thing, and I think it's not just harming ecosystems and the climate, but it's also putting communities at risk, because the focus is on backcountry logging as opposed to where it should be, which is all the very tried and true proven methods to keep communities safe from wildfires. And that work has to be done in the communities themselves, not out in the backcountry. Doug, it looks like your screen is, I don't know if you're frozen there. So it looks like we might have lost Doug.
All right, you want to take over the Q&A thing, Chad?
Let's see. Let me just see a couple other questions. Here's a question. Can you talk a little bit more about the role of drought in the size of fires and tree mortality resulting? Yes, drought is inextricably linked with wildfire and vice versa. Drought cycles are natural, of course. The climate crisis can exacerbate drought cycles. But we typically see throughout history, and there's a lot of good paleo-ecological studies on this, using charcoal records and other things, that the big fire years, going back thousands of years, tend to be associated with drought years, very strongly associated. And so again, it's the weather, it's the climate. If you have a drought year and you've got a lightning ignition and you've got hot, dry, windy conditions, guess what? You're going to have a big fire. It'll happen if the forests are open. It'll happen if the forests are dense. It's not about that. It's about the climate and the weather. And so in terms of tree mortality, there's always tree mortality during droughts. That's natural too. One of the big things, and we didn't get into this in this particular presentation, but it's a big issue, is that when the Forest Service is doing these so-called thinning projects, saying they're going to remove some trees to save more trees from bark beetles and drought, it turns out that the research is indicating they're killing far more trees with their chainsaws than they're preventing from being killed through whatever reduced competition between trees that results from their logging projects. So it's another big fallacy, and it's also, of course, making climate change worse.
Yeah, I'll just add to that. There's an exciting field of climate change modeling now. It's called climate attribute modeling, where we're getting really good at pinpointing particular natural disturbances to emissions. And a lot of this is going into hurricanes right now, but a lot has come out on fires as well. And the two main indicators that drive a lot of the explanatory increases in wildfire acres burning include summertime temperatures like heat domes and the vapor pressure deficit, which is the amount of moisture in the atmosphere if you were to wring it out like a sponge. And those two factors alone in some ecosystems will explain 50 to 100% of the increases in acres burning. So it gets back to that feedback loop. The more emissions we put into the atmosphere, the more we're going to get these drought-like conditions, and the more we're going to get extreme fire weather. And so by scaling up more treatments, you're doing two things. You're having to increase the amount of removal to get an effect, which means you're type converting the ecosystem to something else that it's not. It's a novel ecosystem. Many examples of this in the Southwest, in the Santa Fe watershed that I've been working with groups there, and in Eastern Oregon, and in the Sierra, where we're seeing complete type conversion of forest into more of a weed-infested open savanna system that you could lay down some flame lengths on, but it's going to get increasingly over-ventilated, so you're going to get fire spread moving more quickly. And of course, you're throwing more emissions into the atmosphere. That's going to contribute to the future problems that forests are going to have when they're dealing with the amplification of all of these different disturbance factors that pushes them beyond their capacity to be resilient and across thresholds.
Yeah, well said. So, and there was another question about that the Forest Service says that thinning will reduce fire severity by 60% or 70%. I don't know exactly where those figures came from, but that they'll make those claims in various places. The Forest Service scientists, a number of Forest Service scientists, have produced a series of studies over the past 2 decades, for the most part, that make the claim that thinning reduces fire severity and therefore is something we should scale up dramatically. So a lot of people have been confused by this because they think, well, look, we've got scientists telling us that this works, this is effective. There's a number of things they're not telling you. And we talk about this a little bit in some of our recent papers, in the DellaSala et al. 2022 paper, and in some others. We talk about some of the problems with those studies that have made those claims. So the first and most obvious one is that most of them are theoretical modeling studies. They're not empirical studies. They don't deal with actual fires. They basically are studies where the Forest Service scientists will create the model, create the assumptions that go into the model, and basically control the result. And so if you create the model and the assumptions, and if you build the model around the idea that a less dense forest will burn at lower intensity, of course you'll get that result. And they say, well, the model told us that. Well, you created the model. And so it becomes, kind of absurd. So that's a whole series of them. That's actually the majority. But some of them actually are studies that deal with actual fires. But we see in many of those cases, they're heavily cherry picked. So in other words, you can always find areas that burn at low, that were thinned and burned at low or moderate intensity, just like you can find areas that were very, very dense and burned at low and moderate intensity, because it's mostly about the weather at any moment, and it's highly variable. And so, the Forest Service will find those areas and then do a study about them, but ignore the areas over the ridge in the same fire or an adjacent fire that show the opposite story, where the thinned areas burned at higher intensity. And so there's a lot of cherry picking going on out there. And the way you get around that is by doing larger landscape analyses and using all of the data, which is what we've been doing. And we find that it's really about the weather and climate, and these thinned areas are not burning at lower intensities. Oftentimes it's fairly similar, but what's different, what's really different, and this is a big one, and this is one that all of those Forest Service studies ignore, is the tree mortality from thinning itself, which is oftentimes significantly larger than the tree mortality from the fire. And so the combined tree mortality from thinning plus fire tends to be significantly higher than the tree mortality from fire alone. So you're not removing some trees to save more trees. What they're actually doing is killing a lot more trees and removing a lot of forest carbon. So those are some of the key things, and also some of their analyses, some of their recent meta-analyses have mysteriously omitted every single one of the studies that have found that thinning, or most, they included a couple, but almost all the studies that found that thinning increases fire severity. And there are actually quite a few of those studies. And so there's a lot of cherry picking and omission of evidence, and skewed analyses going on this. I think what we can say is this, and this is what I think is a good summary. Also, I'll put this out there. They often conflate the effects of prescribed fire with the effects of thinning. If you just do prescribed fire alone with no thinning at all, you will get some effect on fire intensity for a short period of time. Not forever, but for a short period of time. And so if they thin and then they do prescribed fire, they may see an effect temporarily from the prescribed burning. It's not necessarily an effect from the thinning. It's kind of a third variable problem. So I think what we know is that weather and climate drive fires overwhelmingly, and that fires tend to move faster through less dense forests, especially forests that have been thinned. We know that thinning increases carbon emissions relative to wildfire alone, and we know the science indicates it kills significantly more trees than it prevents from being killed. And it diverts scarce resources away from home protection and community wildfire safety measures, because we're subsidizing logging in the backcountry. So to me, I think the answer is that we focus on communities and keep the carbon in our forests, and that is a much, much better 21st century solution and approach. Let's see. So we have a comment about the Caldor fire, massive clear cuts and type conversion. Yeah, agreed. It's kind of goes to what Dominic was saying about not just pre-fire logging but also post-fire logging, and kind of the amplification effect that we oftentimes see. So I think I will close it off there. If there are any more questions, feel free to ask. But I think that we'll probably end it there, unless you have any closing thoughts, Dominic.
Yeah, actually, I think we go to what, 1:15 maybe?
Oh, you're right. We do have a few more minutes. Thanks.
Yeah, so I wanted to make sure we don't lose sight of Terry's question there about the Executive Order 14072. And I've said this many times that it gave us a big fat nothing burger, despite 4 years of a lot of people power going into that and trying to get the Forest Service to do the right thing, and then winding up with the National Old Growth Amendment that is not going to get us much, if anything, which is incredibly disappointing. We have to continue to beat this drum because this is the best natural climate solution that we have. And whether it's an old growth forest or a mature forest, and whether those forests have gone through a severe disturbance, they're all part of the natural climate solutions. And we got to continue with that message, continue to hold the line, even though there's a regime change happening on January 20th. We continue to do what we're going to do. The message doesn't change. It just means that perhaps we're more in a defense mode now than we have been in this administration, of course. But we continue to just put out the reasons why these forests are irreplaceable and the only solution to climate change. And even though we are going to get an administration that's going to deny climate change, that doesn't mean that conservation can happen at the local levels, at the state levels, and at the levels that we are currently working at. We just have to buckle down and be ready for probably the biggest challenge of our lifetimes.
Yeah, and we do have a few more minutes. I see there's a question about Eastern Forest too, so I just appreciate that, and want to just mention that some of the things we're seeing, a lot of the things we're seeing, abuses in the Western forests, are also happening in the Eastern forests. A lot of the misrepresentations of natural fire regimes and a lot of mismanagement, and it is worth mentioning that one of the things we're seeing in a lot of Eastern forests is not just a lot of logging under the guise of fuel reduction and restoration in various misleading and destructive ways, but also a misuse of fire in the sense of an overactive, overly aggressive, unnatural hyper frequency of prescribed fire that's being applied in ways that are much more frequent than the natural fire regimes. And I've seen places where it's causing that is actually causing type conversion of forest to non-forest, where I'm seeing in some cases in eastern U.S. forests prescribed burning done on 2-year intervals, where the natural interval historically would have been much longer than that. And so, this is something that I think we need to push back against from coast to coast, because it's being abused and being used in destructive ways, not just in the West, but also in the Eastern forests. And the reality is that denser forests do tend to have more mesic microclimates. They do tend to, based on most of the scientific evidence, burn at lower intensities, all things being equal. Obviously, they can burn at high intensity in the right weather conditions, but they tend to burn at lower intensities. So I appreciate the question about Eastern forests as well. And we may have time for maybe one more. Let me see. One question is, well, why is the Forest Service acting in counterproductive ways? It's it's a really good question. I personally think the answer is complicated. I talk about this a lot in my smokescreen book, but the short answer is, some of it has to do with the money. I think most of it has to do with the money. Okay, it really does. And it's not just the money they make from timber sales. They sell timber, the Forest Service sells timber, and the BLM sell timber to public timber to private logging companies, live trees and dead trees, and they keep the money for their budget. Okay, so that's a perverse financial incentive. That's like an obvious one. But honestly, these days I think they're even more incentivized in the wrong ways from the money they get from congressional appropriations right out of taxpayers' pockets, because the national forests that do the most logging are rewarded by the Washington Office of the Forest Service by larger allocations of taxpayer money to do more and more. They're seen as performers, right? And they get rewarded in that way. But in addition to the money, well, and the money also influences politics, right? Those congressional appropriations, those decisions are made by members of Congress, both Democrats and Republicans, who are getting campaign contributions from the logging industry. So there's a money influence there too. But I think it's partly cultural too. I mean, I've talked to a lot of people in the Forest Service. There's some really good people in the Forest Service and some people who I have real problems with and concerns about. But there are good people in the agency, but they really are in a system that rewards bad behavior and disincentivizes good behavior and adherence to the science. And so some of the best people don't tend to rise through the ranks in the agency, and a lot of it's cultural. There's a real culture of a chainsaw and bulldozer culture in the agency, and they oftentimes tend to think that the solution to every problem can be found at the end of a chainsaw, which is not true.
My parting words of wisdom, having been doing this for 40 years now, we're all feeling it today. And this has been probably the roughest day of my professional life, to wake up this morning and realize what had happened to this country. And yet the sun is still shining outside my window. And we all continue to speak for the voiceless. That's a forest that we care about. Those are the critters that we love, the wild areas that we cherish. None of that changes. We just have to kind of get through this together as a community and realize that we are needed more now than any time in the history of this nation. So hopefully that gets everyone through today, because I am definitely feeling it.
Well, that was very, very well said. I could not possibly say it better. So I think we'll close on that note, because that was pretty much perfect and took the words right out of my mouth. All right. Well, thank you everyone for attending once again, and we will have more JMP webinars in the future, of course. But this concludes this particular series on the second edition of the Nature's Phoenix Mixed Severity Fires Nature's Phoenix book that Dominic and I and so many others worked so hard on to get the science out to people and to create that kind of a resource and reference for folks. All right. Well, thanks everyone for attending. Greatly appreciate it. And we'll see you on the next one.
Live long and prosper.